We'll be discussing few important questions on triangle law of vector addition as well as parallelogram law of vector addition. So in the first question, we have to find x. So we can see this plus this, b plus vector a will give you x as per the triangle law of addition. So x is nothing but vector b plus vector a. Okay, just see they are connected head to tail, and from the loose tail to the loose head, the resultant is the vector. What about this? We can use triangle law as well as polygon law. B plus x will give you a. So b plus x will give you a. So x is nothing but a minus b. Or we could have also done like this. Just draw an opposite vector, which is minus x vector, and as this vector, we can say a minus x is equal to b will get a minus x equal to b. So x is nothing but a minus b. In the next part, a b, we can use polygon law here. Just reverse this vector and call it to be minus c. Again c, this was the c vector and I have reversed it, so it will be called minus c. And then d will give you x. X is the last side of the polygon to close it. So x is nothing but a plus b plus minus c vector plus d. So whatever, you can take c on this side. In this diagram, we can again use that a plus x is d, or we could have also find the value of a or x with the help of b and c. B plus c is nothing but x. So these are the examples in which we can find one vector with the help of other vectors. In the next question, we have to find that what is the value of a plus b vector. What is the range for the value of a plus b vector if vector a is of 5 unit, b is of 3 unit and c is of 1 unit. So we have to find the range of these a plus b. Again, you have to see them as the sides. A and b are the sides and a plus b is the third side. So first side is of 5 unit, another is of 3 unit. So the third side can have a maximum value of 8, sum of these two, and has a minimum value of 2, which is the difference of these two. Again, in the next example, there are again two vectors a and minus b, but still treat them as sides. The one side is of 5 unit, other is of 3 unit. Again, a minus b can be the third side of the triangle. See this. This is the third side of the triangle, which is a minus b. So it may land from again 8 to 2, sum of these two and difference of these two. I'm repeating. Don't see this as the difference of these two vectors. This is basically two vectors, each having a have magnitude 5 and minus b has a magnitude of 3, and we have to find the range for the value of a and minus b. So again 8 to 2. Now 2a and b, there are two vectors. One is of 2a means 10, another is b which is 3. So 10 and 3 may give me 10 plus 3, and a minimum value will be 10 minus 3, which is 7. 2a minus b will again 10 plus 3 and 10 minus 3. What is the maximum value of a and a plus b plus c, or the maximum value of a minus b plus c, or anything else? So the maximum value of this can be 5 plus 3 plus 1, and this can also be 5 plus 3 plus 1. This is the maximum value of any linear combination of a, b and c that can take place. What about 3b minus 2a? Now there are two vectors. One is 3b means of 9 magnitude and another is of 10 magnitude. So maximum they will give you 10 plus 9 and the minimum they will give you 10 minus 9. this will be in between 19 and 1. Thank you. In this question, we have to find the direction of A and B for the following equations. In this, A vector plus B vector is giving C. So C must start from the loose tail to the loose head. So this should be the head of B and this should be the head of A. Okay. We have to give the arrows to A and B. Again, C is the resultant of A and B. C should start from a loose tail to loose head. So this is the loose tail, this is the loose head. Similarly, in this vector C, we can also change this equation to vector A is equal to B plus C. So A is the resultant of B and C. So this is the loose tail. So A should start from here and should be here, and B will be like this. B plus C will give you A. Similarly, in this, we can say B is the resultant of C vector and A vector. So just think B should be from loose tail to loose head. So head is here. This should be the head of B and this is the tail. So A should be like this. A plus C will give you B, and this C plus B will give you A, and in this A plus B will give you C. In this question, we have to find there is a triangle and a side AB is given as vector A, C the head, and side AC is given as vector B. We have to find CB, CD and AD vector. Again, AB vector is from A to B. AC vector is from A to C. Similarly, CB vector will be this, C to B, and CD vector will be like this, C to D. So we have to find these vectors. Given one more information is given that CD is to CB is 2:1. So this length is double. Let's say this is L. So this is 2L. This length is double that of this. So we can say, using again triangle law, that vector AC plus vector CB will give you vector AB. So CB is nothing but how much? AB minus AC, which is AB is vector A and AC is vector B. So CB is nothing but this. And what about CD? In vector form, we can say CD is negative of twice of CB. Again, because this CD is in upward direction and CB is in downward direction, so they are opposite in direction, and the magnitude of CD is double of that. So CD is nothing but minus 2 A vector minus B vector. And again, from the triangle law, we can get AD as AC vector plus CD vector. So AC is nothing but B plus minus 2 times vector A minus vector B. That will give me 3B minus 2A. Okay. In these examples, we have to find the relation between vector A, B and C and the angle between them. Theta AB, theta BC, theta CA. So let's look at the first example. In this, we have to find relation between A, B and C. As we can see, A plus B plus C will give you 0. They are forming a closed triangle in an order. We can say this is 0. And theta AB is very clear, that is 90 degree. What about theta BC? To find the angle between vector B and C, we have to join them tail to tail, and this will be theta BC. So theta BC is nothing but 150 degree, 180 minus 30. Similarly, to find the angle between A and C, we have to join them tail to tail. So we have to make the C forward, and this angle will be called theta AC. So theta AC is nothing but 180 minus 60, which is 120 degree. In the next example, look at this. A, B will give you C. So the equation is A plus B is giving us C. Again, the angle between vector A and vector B, we have to extend it, join them by tail to tail. So this angle is nothing but 130 degree. And B and C, we can extend them. The angle will again remain 70 degree. And as C and A are already joined tail to tail, the angle is 60 degree between A and C. For this, this B and A will give you C. So B plus A is nothing but C. The angle between AB, we have to extend B. So this is nothing but 120 degree. And B and C are already, so this is 70 between the A and B. And A and C are joined head to head. So this is the same angle as when joined tail to tail, which is 50 degree. Similarly, in this, we can say again the equation is A plus B is equal to C, as B and A will give you C. So the angle between them will be, just extend B. So this is the angle between A and B, which is 140 degree. Angle between B and C is 50 and A and C is 90. Okay.